And now we go to modulators. Modulation is the process of adding information to an unmodulated radio frequency RF signal, also known as the carrier signal. Circuits that perform the modulation process are called modulators. Here is an example of an AM waveform where a 10 kHz carrier is being modulated by a 1 kHz signal. One way to generate a single sideband signal is to use a filter to remove the carrier and one of the sidebands from an ordinary double sideband AM signal. Another way to generate a single sideband signal is to use the quadrature method. This requires generating 90-degree phase shifts of the audio and RF signal. This is most easily accomplished with digital signal processing using special combination filters called the Hilbert transformer. This is the schematic of a reactance modulator. It produces direct frequency modulation. It consists of a varactor diode or a transistor which produces variable reactance in the frequency producing circuit of an oscillator. Here is an example of how you could use a reactance modulator. The audio input signal causes the capacitance of the varactor to change, which changes the inductor-capacitor ratio of the oscillator's tank circuit and its frequency. What is one way a single sideband phone signal can be generated? A, by using a balanced modulator followed by a filter. B, by using a reactance modulator followed by a mixer. C, by using a loop modulator followed by a mixer. Or D, by driving a product detector with a double sideband signal. The answer is A, by using a balanced modulator followed by a filter. What type of digital signal processing filter might be used to generate a single sideband signal? A, an adaptive filter. B, a notch filter. C, a Hilbert transformer filter. Or D, an elliptical filter. The answer is C, a Hilbert transform filter. What circuit is added to an FM transmitter to boost the higher audio frequencies? A, a de-emphasis network. B, a heterodyne suppressor. C, an audio prescaler. Or D, a pre-emphasis network. The answer is D, the pre-emphasis network. The next subject is demodulators or detectors. Here is a very simple AM detector known as a cat's whisker. It works as a diode to detect the AM waveform. During World War II, soldiers made AM detectors using rusty razor blades and a needle. The principle was the same: fashion a diode from whatever materials you could find. The simplest type of detector is a diode detector. It rectifies, then filters the received RF signal. A product detector is a type of mixer that combines the incoming RF signal with a locally generated beat frequency oscillator signal. The BFO signal frequency is chosen so that one of the sum of different signals is at audio frequencies. A product detector follows the IF stages. The direct conversion detector works much like the product detector. It is simpler, but is subject to microphonics. Microphonics are mechanical vibrations that change the oscillator frequency and thus become part of the recovered signal. A frequency discriminator uses a transformer tuned to the receiver's IF to detect FM signals. How does a diode detector function? A, by rectification and filtering of RF signals. B, by breakdown of the Zener voltage. C, by mixing signals with noise in the transition region of the diode, or D, by sensing the change of reactance in the diode with respect to frequency? The answer is A, by rectification and filtering of the RF signals. What is meant by direct conversion when referring to a software-defined receiver? A, software is converted from source code to object code during operation of the receiver. B, incoming RF is converted to the IF frequency by rectification to generate the control voltage for a voltage-controlled oscillator. C, incoming RF is mixed to baseband for analog to digital conversion and subsequent processing. Or D, software is generated in machine language, avoiding the need for compilers. The answer is C, incoming RF is mixed to baseband for analog to digital conversion and subsequent processing. Our next subject is frequency synthesis. In a phase lock loop, the frequency of a variable oscillator is continually compared to the phase of a stable fixed frequency reference oscillator. This phase difference is used to change the frequency of the variable oscillator. Direct digital synthesis is based on the concept that we can define a sine wave by specifying a series of amplitude values spaced at equal phase angles. The frequency of the output sine wave is determined by the rate at which the synthesizer steps through those values. Why is a phase lock loop often used as part of a variable frequency synthesizer for receivers and transmitters? A, it generates FM sidebands. B, it eliminates the need for a voltage-controlled oscillator. C, it makes it possible for a VFO to have the same degree of frequency stability as a crystal oscillator. Or D, it can be used to generate or demodulate SSB signals by quadrature phase synchronization. The answer is C, it makes it possible for a VFO to have the same degree of frequency stability as a crystal oscillator. What information is contained in the lookup table of a direct digital frequency synthesizer? A, the phase relationship between a reference oscillator and the output waveform. B, the amplitude values that represent a sine wave output. C, the phase relationship between a voltage-controlled oscillator and the output waveform. Or D, the synthesizer frequency limits and frequency values stored in the radio memories. The answer is B, the amplitude values that represent a sine wave output. And now we'll look at filters and impedance matching. Passive filters are made from unpowered components such as resistors, capacitors, and inductors. This always results in some loss of signal amplitude. Active filters include powered devices to overcome filter insertion loss. Sometimes they even provide signal gain. Butterworth, Chebyshev, and elliptical are names that refer to the family of equations used to design that type of filter. Other terms that apply are cutoff, ripple, and phase response. Active filters are a lot of fun to design, build, and use. They follow a cookbook design format. The characteristics of the active filter can be changed in terms of gain, corner frequency, and type of response by varying component values and the circuit layout.